Year 11. In this lesson we're going to look at algebraic expansion and factorisation. Remember that expanding and factorising are opposite operations. Let's remember that when we have binomial products like a plus b all squared, a minus b all squared and a plus b times a minus b, these can be simplified by writing, in the first case, a plus b times a plus b. We can use the FOIL method to expand those brackets. So we have a times a, multiply the first terms together, giving us a squared. Then we multiply the outside terms, a times b, gives us plus ab. Multiply the inside terms, which gives us plus AB, and finally multiply the outside terms, which gives us plus B squared. This can be simplified to A squared plus AB plus AB is 2AB plus B squared. We can do the same thing with the next binomial product. And that will give us a squared minus 2ab this time, plus b squared. The last one, a plus b times a minus b, gives us a difference of squares. So we end up with a squared minus b squared. With the expressions on the right-hand side, a to the power of x times b to the power of x, that's the same as writing AB all to the power of x. A to the x times a to the x. There's a couple of ways we could think about that. Firstly, we could do the same as we did before and write a squared all to the power of x, which is the same as a to the power of 2x, using the power of the power law. 3 to the x times 3 to the x is the same as 3 squared to the x, or 9 to the power of x. With example 1, we have 2 to the power of 2x plus 3 lots of 2 to the power of 2x. What's important to see here is that we have one lot of 2 to the power of 2x here, and 3 lots of 2 to the power of 2x there. So one lot of 2 to the power of 2x plus 3 lots of 2 to the power of 2x gives us 4 lots of 2 to the power of 2x. 2 to the power of 2x is the same as 4 to the power of x, so that's 4 lots of 4 to the power of x, or just 4 to the power of x plus 1, using our index law for multiplication. Example 2, we're going to multiply the term outside the brackets by each term inside the brackets. Using the index law for multiplication, we have 2 to the power of 2x times 2 to the power, 2 to the power of x times 2 to the power of x, which gives us 2 to the power of 2x. Plus 2 to the power of x. In example 3, we're going to do the same thing. This time we have 3 terms inside the brackets. And we're going to need to use our index law for multiplication once again. We'll multiply the term outside the brackets by each term inside the brackets. So x to the minus a half times x to the power of 3 on 2 gives us x to the power of minus a half plus 3 on 2, which is x to the power of 1. Plus x to the minus a half times 2x to the half will give us 2x to the power of 0. Then x to the minus a half times minus 3x to the minus a half will give us minus 3x to the power of minus a half plus minus a half, or just minus a half minus another half, which is minus 1. We can rewrite this as x plus 2, because x to the power of 0 is 1, minus 3 over x, because x to the minus 1 is the same as 1 over x. Looking at a further example, here we have a binomial product where we want to again use the FOIL method. So we'll multiply the first terms together. 3 to the power of x times 3 to the x will give us 3 to the power of 2x. Then we're going to multiply the outside terms together. 3 to the x times 5 will give us 5 lots of 3 to the x. Multiplying the inside terms together will give us plus 2 lots of 3 to the x. And then finally multiplying the outside terms together will give us plus 10. We can simplify this by writing 3 to the power of 2x. Now 5 lots of 3 to the x plus 2 lots of 3 to the x is 7 lots of 3 to the x. And then plus 10. We could also write this as 9 to the power of x plus 7 lots of 3 to the x plus 10. There's another way we could have done this. We could let some pronumeral like m equal 3 to the x. What we would have then is m plus 2 times m plus 5. Expanding the brackets would give us m squared plus 7m plus 10. And because m equals 3 to the x, we can replace m with 3 to the x and write 3 to the x all squared plus 7 lots of 3 to the x plus 10. Which equals 3 to the power of 2x plus 7 lots of 3 to the x plus 10, and that's the same as what we had earlier. When we have a binomial product like 4 to the x plus 7 all squared, remember that that can be rewritten as 4 to the x plus 7 times by itself. Using the FOIL method, multiply the outside terms, 4 to the x times 4 to the x is 4 to the power of 2x, plus 7 lots of 4 to the x, plus another 7 lots of 4 to the x, plus 49, which equals 16 to the power of x, plus 14 to the power of 4x, plus 49. Let's turn our attention to factorising now. When you see 5 to the power of 2x, remember that can be written as 5 to the power of x all squared. You can check by using the power of the power law that 5 to the x all squared is the same as 5 to the power of 2x. So we have 5 to the power of x all squared plus 5 to the power of x. Taking out the common factor of 5 to the power of x leaves 5 to the power of x plus 1. When we see an expression like 9 to the power of x minus 4, we need to write each term with the smallest base. In this case, this is the same as 3 to the power of x all squared minus 2 squared. Can you recognise that expression? Hopefully you'll see that that is a difference of squares, which can be written as 3 to the power of x plus 2 times 3 to the power of x minus 2. Remember, a difference of squares has the form a squared minus b squared, which equals a plus b times a minus b. Here a is the 3 to the power of x, and b is the 2. With example 3, once again we need to try to write that first term with the smallest possible base. So 4 to the x is the same as 2 to the power of x all squared. At this point, what we could do is let some prime numeral like m equal 2 to the power of x. So then the expression becomes m squared plus 9m plus 18, which we can then factorise to become m there. Let's say we want a pair of some factors of 18, 3 and 6. And 3 and 6 can add together to give plus 9. So we can write m plus 3 and m plus 6. We should always check by expanding. M times m is m squared. M times 6 is 6m plus 3m is 9m, and 3 6s are 18. So that works. Lastly, we need to replace the m with 2 to the x. So we get 2 to the x plus 3 times 2 to the x plus 6. Let's look at question 4 now. We have 12 to the power of n over 6 to the power of n. I could break the 12 up into some factors, like 2 times 6, and then write the whole thing to the power of n over 6 to the power of n. That's the same as 2 to the power of n times 6 to the power of n all over 6 to the power of n. We can cancel the 6 to the power of n's, leaving us with 2 to the power of n. Alternatively, I could also rewrite 12 to the power of n over 6 to the power of n as 12 over 6 all to the power of n, which equals 2 to the power of n. In the last example, 5, we have 6 to the m plus 2 to the m all over 2 to the m. What I should do here is look at factorising the 6, so I can write 6x to the power of n as 2 times 3 to the power of n, all to the power of n that is, plus 2 to the n, all over 2 to the power of n. This becomes 2 to the power of n times 3 to the power of n plus 2 to the power of n all over 2 to the power of n. In the numerator, 2 to the power of m is a common factor. So I can take that outside the brackets and write 2 to the power of n. In the first term, I'm left with 3 to the power of n. And then I can add 1. All over 2 to the power of n. The 2 to the power of n's can cancel. And that leaves me with 3 to the power of n plus 1. Thanks for watching. I hope that helps you answer some of the practice questions.